Now in the question 13, the daily maximum temperature at a town in a particular year was recorded. The commutator frequency curve below shows the daily maximum temperature x degrees centigrade and the number of days when the daily maximum temperature exceeded x degrees centigrade. So in the part 1, use the curve to estimate the number of days when the daily maximum temperature exceeded 30 degrees. First, we have to understand the scale along x-axis. So here we have 27 minus 26 divided by the number of squares between these 2 points, and that is 5. So it will be equals to 1 over 5, and it will further equals to 0.2. So the each square unit along the x-axis is equals to 0.2. Now the scale along y-axis, we have 50 minus 0 divided by number of square between these 2 points, that is 5. So 50 over 5 is equals to 10. So each square unit along the y-axis is equals to 10. Now to find out the number of days when the daily maximum temperature exceeded 30 degrees Celsius can be found from the curve. So along x-axis from the point 30, we will draw a vertical line until it intersects the curve. Now from the point of intersection on the curve, we will draw a horizontal line until it cuts the vertical axis. Since we know that each square unit along the y-axis is 10, so here we have 300, 310 and 320. So the value is 320. The reading we get is equals to 320. So the number of days when the daily maximum temperature exceeded 30 degrees Celsius is equals to 320. Now the part 1b, use the curve to estimate the fraction of the days that had a daily maximum temperature of at most 32 degrees Celsius. So from the curve, first we have to find out the number of days when the daily maximum temperature exceeded 32 degrees Celsius. So from 32, we will draw a vertical line until it intersects the curve. Now from the point of intersection on the curve, we will draw a horizontal line until it touches the vertical axis. So it is approximately 155. So the number of days when the daily maximum temperature exceeded 32 degrees is equals to 155. But we have to find out the number of days that had daily maximum temperature of at most 32 degrees. So to find out the number of days when the daily maximum temperature was at most 32 degrees Celsius, we can find out the number of days when the daily maximum temperature was at most 32 degrees Celsius by subtracting the number of days when the daily maximum temperature was exceeded 32 degrees Celsius from the total number of days. So in a year, the total number of days are 365. So we will subtract 155 from 365 and it will be equals to 210 days. So 210 days when the daily maximum temperature was at most 32 degrees Celsius. Now to find out the fraction of days, that had a daily maximum temperature of at most 32 degrees Celsius is equals to the number of days we have find out that had a daily maximum temperature of at most 32 was 210 divided by the total number of days, and that is 65. Now after further simplifications, we will get 42 over 73. So the fraction of days that had a daily maximum temperature of at most 32 degrees Celsius is equals to 42 over 73. Now in the part 1c, use the curve to estimate the value of K given that 165 days had a daily maximum temperature of K Celsius or less. So if 165 days had a daily maximum temperature less than or equals to K degrees Celsius, then we can find out the number of days that had a daily maximum temperature exceeded to K degrees Celsius. So we can find out it just by subtracting the number of days that had a daily maximum temperature less than equals to K Celsius from the total number of days. So 365 minus 165 will gives us 200. So the number of days that had a daily maximum temperature exceeded K degrees Celsius is equals to 200. Now from the curve we can find out the value of K. Now from 200 along the y-axis we will draw a horizontal line until it intersects the curve. Now from the point of intersection on the curve we will draw a vertical line until it touches the x-axis. So now here we have 31.2, 31.4 and 31.6. So here the value will be 31.6. So the value for K from the curve is equals to 31.6 degrees Celsius. Now in the part 1D, use the curve to estimate the number of days. Choose it at random from the year. Find the probability that the day had a daily maximum temperature of at most 32.4 Celsius. Along x-axis here we have 32, 32.2, 32.4. So from 32.4 we will draw a vertical line until it touches the curve. Now from the point of intersection on the curve we will draw a horizontal line until it touches the y-axis. And since we know that each square unit along y-axis is equals to 110, so here we have 100 and here we have 110. So the number of days that has a daily maximum temperature of at most 32.4 degrees Celsius equals to 110 from the curve. From the curve we will find out the number of days that had a daily maximum temperature exceeded 32.4 degrees Celsius, and that is equals to 110. Now to find out the probability that the day had a maximum temperature of at most 32.4 degrees Celsius, we will subtract the value that we have found out from the curve, and that value was the number of days that had a daily maximum temperature of exceeded 32.4 degrees Celsius. So here we will subtract 110 from the total number of days 365 and divided it by the total number of days, and that is 365. So here we have 365 minus 10, here we have 5 and here we have 5 and here we have 2, so we have 255 divided by 365. With the table of 5 here we have 5 5 25, 5 1s are 5, and here we have 3 7s are 35 and 5 7s are 35 and 5 3s are 15. So it will be equals to 51 over 73. So the probability the day had a daily maximum temperature of at most 32.4 degrees Celsius is equals to 51 divided by 73. Now in the question 14, the speeds of 100 bicycles on a cycling lane at a particular park are recorded. The commutator frequency curve below shows the speed u km per hour and the number of bicycles which traveled at a speed less than or equal to u km per hour. So in the part 1 A. Use the curve to estimate the number of bicycles that traveled at a speed of at most 18 km per hour. First, we have to understand the scale along x-axis. So here we have 5 minus 0 divided by the total number of squares between these 2 points, and that is 5. So 5 over 5 is equals to 1. Now the scale along y-axis, we have 10 minus 0 divided by 5, and it will gives us 10 over 5, so it will be equals to 2. So each square unit along x-axis is equals to 1, and each square unit along y-axis is equals to 2. Now to find out the number of bicycles that traveled at a speed of 18 km per hour can be found out by using the curve. So from 18, after 15 we have 15, 16, 17 and 18. Now from 18, from horizontal axis we will draw a vertical line until it intersects the curve. Now from the point of intersection on the curve we will draw a horizontal line until it touches the vertical axis. So here we have the reading of approximately 10 and 12 versus 13. So the number of bicycles that travel at most at a speed of 18 km per hour, speed of at most 18 km per hour is equals to 13. So part 1b, we have to find out the fraction of the bicycle that traveled at a speed greater than 25 km per hour. So to find out this, first we have to find out the number of bicycles that traveled at a speed of at most 25 km per hour. So from 25 along the x-axis, we will draw a vertical line until it cuts the curve. Now from the point of intersection of the curve, we will draw a horizontal line until it touches the vertical axis. So here we have 52 and 54. So here we have the reading 54. So the number of bicycles that traveled at a speed of at most 25 km per hour is equals to 54. Now to find out the number of bicycles that travel at a speed of greater than 25 km per hour, we will subtract the number of bicycles that traveled at a speed of at most 25 km per hour from the total speed, from the total number of bicycles. So here we have 100 minus 54, and it will be equals to 46. So the number of bicycles that traveled at a speed of greater than 25 km per hour is equals to 46. Now to find out the fraction of bicycles that traveled at a speed greater than 25 km per hour is equals to the number of bicycles that traveled at a speed of greater than 25 km per hour. So that was 46 divided by the total number of cycles, and that is 100. Now after simplification, we will get 2 to the 4 and 2 3 is 6. So it is equals to 23 divided by 2 5 is 10 and 0, so it is 50. So the fraction of bicycles that traveled at a speed greater than 25 km per hour is equals to 23 or 50. Now for part 1c, the value of v if 40% of the bicycles traveled at a speed less than or equal to v km per hour. So first we have to find out the 40% of bicycles, and that is equals to 40 divided by 100 multiplied by total number of cycles multiplied by 100. So 100 cancel out with 100. So this is equals to 40 bicycles traveled at a speed of less than or equals to v kilometer per hour. So now from the curve we can find out the value of v. From the vertical axis y, since we have 40 bicycles, so from 40 along that y-axis we will draw a horizontal line until it touches the curve. Now from the point of intersection on the curve we will draw a horizontal line, a vertical line, until it touches the y-axis, x-axis. So here we have 20, 21, 23. So the value is 23. So 40% of the bicycle travel at a speed less than or equals to 23 km per hour. So the value of 3v is equals to 23 km per hour. Now for part 2, the speed limit of a bicycle on a cycling lane is 25 km per hour. A newspaper article states that 50% of cyclists do not keep the speed limit. Comment on whether the data in the question support his claim. From the part 1b, 40%, 46% of cyclists exceeded the speed limit of 25 km per hour. Therefore, the data does not support the claim that 50% of the cyclists Do not keep the speed limit. If two bicycles are selected at random from the 100 bicycles, find the probability that both bicycles exceeded the speed limit. Since we have find out the number of bicycles that exceeded the speed limit and there was 46 divided by the total number of outcomes and that is 100 multiply by, since we have to find out the two bicycles, so we have already selected one bicycle, so the number of bicycles are left will be 99. And since we have already selected one bicycle from the bicycles that have exceeded the speed limit, so the number of bicycles that exceed the speed limits are left will be 45. Now with the table of 5, here we have a 5 nines are 45, and here we have the 5 2s and then there's a 0, and here we have the 9 1, the 9 and 99 is a 11. So here we have, can make further simplifications. Here we have with the table of 2 2 2s are 4 and 2 3s are 6, and here we have 2 tens are 20. So here we have 23 divided by 110. So the probability that both bicycles exceeded the speed limit is equals to 23 over 110. In the part 4, copy and complete the following cumulative frequency table for the data given in the cumulative frequency curve. So along the x-axis, speeds given in the kilometer per hour. So from the x-axis, we will write down the missing speed values. So here we have, after u less than equals to 15, u less than equals to 20. Then we have u less than equals to 25. Next value will be u less than equals to 30. And the second last value will be u less than equals to 35. Now to find out the cumulative frequency, we will draw a vertical line from point 10 until it touches the curve. Now from the point of intersection of the curve, we will draw a horizontal line until it touches the y-axis. So here we have the value 3. So the value of the cumulative frequency for u less than equals to 10 is equals to 3. And now from 15 we will draw a vertical line until it intersects the curve. Now from the point of intersection on the curve, we will draw a horizontal line until it touches the y-axis. So here we have the value 8. So the cumulative frequency for u less than equals to 15 is equals to 8. Now for 20, we will draw a vertical line until it touches the curve. From the point of intersection of the curve, we will draw a point of intersection of the curve. We will draw a horizontal line until it touches the y-axis. So here we have the value 20. So for speed u less than equals to 20, we have the cumulative frequency of 20. Now from 25, we will draw a horizontal line until it touches the curve. Now from the point of intersection on the curve, we will draw a horizontal line until it touches the vertical axis. So here we have the value 54. So the cumulative frequency for u less than equals to 25 is equals to 54. Now from 30, we will draw a vertical line until it touches the curve. So now from the point of intersection on the curve, we will draw a horizontal line until it touches the vertical axis. So we have the reading 76. So the cumulative frequency for u less than equals to 30 is equals to 76. Now for 35, we will draw a horizontal line until it touches the curve. Now from the point of intersection on the curve, we will draw a horizontal line until it touches the vertical axis. So here we have the value 90. Now for the last value 40, we will draw a horizontal line until it touches the curve. Now from the point of intersection on the curve, we will draw a horizontal line until it touches the vertical axis. So here we have the value 100. So the cumulative frequency value for u less than equals to 40 is 100. So here we have completed the cumulative frequency table from the data given in the cumulative frequency curve. Now in the question 15, the cumulative frequency curves for the daily mobile data usage of three groups of participants in a survey are shown below. Each group has 100 participants. Out of three groups, explain which of them is likely to have participants who use in the part 1 the least mobile data. So, according to the given curve, if we observe the group B cumulative frequency curve, the answer that the least mobile participants who use the least mobile data usage are of group B, because the curve cuts the origin and the start of the curve is the steepest. Of the three curves, meaning it has the most people with. The least mobile data usage. Now for the part 2, the most mobile data usage. So the answer is group C, because the curve does not cut the origin and the start of the curve is gentlest of the three. meaning it has the most number of people having a high mobile data usage. We can easily check the trend of the cumulative frequency curve for the group B, since it is increasing at the start and then with the passage of time it decreases. So it means here we have the number of people having a least mobile data usage, and for the group C, the one interesting thing to note that it does not start from the zero origin, and at first it decreasing, and with the passage of time it's increasing. So it shows the number of people having a high mobile data usage.